Hi, thanks for joining us here in the International Space Station Flight Control Room. I'm here with Capcom Hal Getzelman, and we are excited to take your questions.
Hi, I'm Victoria, and my question today is what jobs and duties do you perform in mission control?
So I'm a capsule communicator, and my job is to talk to the crew on orbit. And what I do is I listen to all the conversations that the experts are having here on the ground, and then I work together with the flight director and then explain it to the crew on orbit exactly what's going on and try to understand what they need to know and give that information in a way that's useful to them.
Hi, pleasure to meet you. My name is Sam, and I'm going to ask you a question today. What tests are they performing on the International Space Station for sending people to Mars?
Well, we're performing a lot of activities on board, and a lot of those will help us learn the skills and test the equipment that we'll need. A good example is exposure to radiation. Our crews carry around dosimeters, little devices that measure their radiation exposure, and we track that throughout the mission. Also, we have equipment on board that removes carbon dioxide. We have equipment that takes water and separates it into hydrogen and oxygen so the crew will have something to breathe. We also are obviously put on board provisions of food and clothing that they would, of course, need for their trip to Mars. So we are learning to live for 6 months at a time. We're going to have one mission in the near future for 1 year on orbit. And of course, as you might suspect, to go to Mars is going to take us anywhere from a year to 2.5 years a round trip. So we need to get quite a bit of experience in this regime.
Hi, my name is Ethan. My question today is how much does it cost to send a mission into space?
Well, it costs a lot of money. When the space shuttle program was going on, it was about $4.5 billion a year program itself. But everything costs an extraordinary amount of money because we don't have the ability to go to the corner hardware store to get spare parts, and so all of our equipment has to go through rigorous design and testing, and a lot of people get involved with that, and so therefore it's very expensive. So you're talking millions and billions of dollars to do things that on Earth would cost much less, but because we're in space, they do cost a considerable amount of money.
But we should also add that we learn a lot from doing that, and there's a lot of technologies that we use on Earth in our everyday lives that have come from that investment in the things that we're developing for spaceflight.
Absolutely. A lot of the technologies of miniaturization, of taking very large computers and shrinking them down to where we see today, that effort was all begun because we needed computers that were small enough to fit in our spacecraft to go to the moon.
And things like the cell phones that they use, smartphones, and even some of the sports equipment that probably some of you kids use have all sometimes have derived from space technology.
Thank you. So, my name is Jack, and I was wondering, what do you do for communication systems with Mission Control 2 with the ISS? What do you do if they fail or malfunction?
Okay, so it's very important to us that we can communicate with the crew, and we do that several different ways. One way is, of course, voice communications, where we are just talking back and forth. Another very important way is video, where we actually see the crew and see what they're doing, and we can observe where they're at in a particular, like an extravehicular activity, a spacewalk. And also we get a lot of telemetry data that's coming down from the space station, so we can see the status of systems and all that. All that communication is very important to us. And so we have quite a bit of redundancy in the system. So we have two separate strings of equipment for the voice. We recently upgraded the communication system to allow voice through our a different frequency band than what we were using before. So we actually have 4 different channels of communications we can talk to the crew. The Russian segment has its individual system of VHF communications. So together we have quite a bit of redundancy. So if one system should fail, we can continue to talk to the crew in sort of a reduced, effective way, and then we can get it fixed.
Hello, my name is Cherry, and my question is, what happens if an asteroid comes shooting towards International Space Station?
Well, that's a very good question, because I'm sure many of you have seen on television an asteroid that came into the atmosphere over a Russian city, and so it's getting a lot of thought. In the space station, we're able to track most large objects that are in orbit around the Earth, and any time that one of those known items is going to pass close to the space station, we try to move the space station out of the way. In other words, a day or two prior, we'll adjust the orbit by usually boosting it out of the way, so that when that object passes, it passes well clear. Now, asteroids are a little different, because they are not as well known and as well predicted. But if we did know one was coming close, we could take actions to maneuver the space station out of the way.
Thank you. Hi, my name is Allie, and my question is, how are the satellites powered so long without having any cords? And do you control any satellites from the station?
Okay, well, again, that's an interesting question. In most of our satellites that orbit around the Earth, they have solar panels, solar collectors, and that produces the electricity they need. For further stability in that system, they also have batteries, and so the solar panels collect the electricity that's converted sunlight and charge up the batteries. And even when the satellites go in the shade of the Earth, because remember, as they are in orbit around the Earth, a lot of times, and the same with our space station, when we go on the side opposite the sun, we're in the shade, so we use the battery power for that. Some satellites, like the rover on Mars, actually use nuclear power, and they have a isotope that is fairly hot, and they use a thermocouple device to harvest that heat energy and convert it into electricity. So that's why they don't need the cords or anything. And I think the second part of your question is, we don't directly today control any satellites from the space station. We have launched a few small satellites, and the crew has released those from the space station, and they're passive. They just orbit until they re-enter the atmosphere and burn up.
Hi, my name is Aisha, and my question for you today is what is the training and how many years does it take to become an astronaut?
Well, it starts way back when, right when you guys are there. All of our astronauts are excellent students, they're excellent learners, and they excel and thrive on learning and accumulating knowledge. And they have done that their whole life. Most of our astronauts are in their 30s by the time they get selected to become astronauts. They're picked from a large pool of volunteers, and we're trying to pick the best candidates for those jobs. And it doesn't, we have a lot of different ideas. They're not all test pilots. Some are doctors, some are geologists, some are oceanographers. So they come from a lot of different scientific and technical backgrounds. Um, Once they're picked to be an astronaut, it takes about a year and a half to do the basic training. And then they go on to advanced training, which probably will take another year before they're assigned to a mission. And once they're assigned to a mission, it takes another 2.5 years before they're actually on board the space station. So actually, you can see that's about 5 to 6 years of training once they're selected as astronauts. Some have been around as long as 10 years before they fly.
And I think part of the question was what does the training entail? And a lot of that, I think folks would be surprised. They have a lot of classroom training too. So just like you in school, they're a lot of times studying in a classroom setting with book studying, trying to learn the systems, the space station systems, how all the different oxygen systems, thermal systems, all those things work. So some of it's similar to what you do, and then other times they're in a mock-up, which is kind of like a pretend space station, and that's where they're rehearsing the procedures and learning how to work with a team. Other thoughts, Hal?
No, that's quite true. And also, they have to do a lot of language training. Since our astronauts are working with Russian crew members, and mission control in Moscow often communicates in Russian, they need to be competent Russian speakers. So another challenge for our astronauts.
Hello, my name is Andy. My questions for today is, since all space shuttles have been decommissioned, how do you get supplies, food, and people up in the space station?
Okay, well, that's a good question because obviously the crew cannot get by without food and water. And we have several resupply cargo ships. We have the Progress, which is a Russian cargo vehicle. We have the ATV, the Ariane Transfer Vehicle, which one was just launched out of French Guiana here yesterday. It's a very large cargo vehicle, bringing up a lot of food and water and spare parts. We have the Dragon space capsule from a private firm of SpaceX, and the Cygnus cargo vehicle will be coming up this fall sometime. And also we have the HTV, which is a Japanese cargo vehicle. So we have several cargo vehicles available to us to bring up that food and water now that the space shuttle is retired. Our only vehicle to actually bring the crew up is a Russian-built vehicle called the Soyuz. It carries a crew of 3. And we're hoping with commercial crew and with our Orion program to develop a new launch vehicle, an American-built vehicle that can also bring crew up to the space station.
Hi, I'm Annie. What has been the most memorable or exciting moment for you two in the control center?
Well, for me personally, we have sort of busy times and we have times that are not quite so busy. So I think of myself, the most exciting time for me was when we brought up Node 3 and the cupola, and we attached that to the International Space Station. That was the last major item that was going to be attached to the space station. There was a few other experiments and a sort of big closet that we brought up later, but this was the last big module. And to be part of that mission and see that the space station would finally be completed was a very exciting moment for me. It was kind of like seeing the Empire State Building or the Hoover Dam first become operational, finally finish its initial construction and be declared operational. So that was a very exciting time for me.
Yeah, I'm sure that Michael has told you guys the space station is as big as a football field. It's really, really huge and hard to imagine in space, but it had to be built piece by piece with different modules being flown up some of those modules were built in other countries, and they were all brought up there individually and pieced together. So for people like Hal who've worked on it for a long time and been a part of it, to see it being built over years, it was probably a big deal to see it come together. And the cupola, of course, is a special piece because it has all the windows. So that's a favorite spot for the astronauts on the space station, where they go and literally it's almost like going into a bay window where there's windows on every surface, and they can look out and just see a wide panoramic view of the Earth. So it's a special place.
Yeah, I think back one of the books that they had us read when we were young was Jules Verne, 20,000 Leagues Under the Sea. And his submarine had a big picture window in the front of the submarine, and so the cupola is kind of this big window that you get to look out at the Earth below. And I've had crew members tell me that it has such an impact on them that it actually brings them to tears to look out that window.
Hi, my name is Jordan, and my question is, what is everyday life in the command center and the space station?
Well, every day is a little different, as you might imagine. But let me give you a thumbnail sketch of what it's like. We operate on Greenwich Mean Time, and the crew gets up at about 6 o'clock Greenwich Mean Time. For us, that's about 1 o'clock or midnight here in Houston. So we bring in a control team. There's 3 control teams. We each work about 8-hour shifts and hand over to the next shift. The crew gets up, does their normal things of waking up and getting dressed and having breakfast and all that. We talk to them first thing in the morning, kind of tell them what's going on and any important developments that may have happened while they were sleeping. And then they start into their routine. We work really hard to keep the crew busy, and we have them assigned tasks, basically a flow chart of the activities for the day, and the crew works through those. We help them with that. We take actions on the ground to maybe save some equipment, turn it off before they change out a part or something like that, and they work through till about lunchtime. While this is going on, the crew actually has about 2.5 hours of exercise during the day. They do half of their exercise would be aerobic, that's like running or pedaling a bicycle. The other half is strength training, and they do that on our resistive exercise device. And so they work that into their schedule. After lunch, they have more activities. Around about 3:30 in the afternoon, we kind of wrap up the work day for the crew, and then they have about an hour and a half to kind of have supper, get settled down, take care of their own sort of interests, and then they go to bed for 8 hours and get up and do it again. On the weekends, Saturday morning, they do a lot of house cleaning, vacuuming, swabbing down areas of the hull, and inspecting things. The rest of the Saturday is usually free time for what they want to do. Sunday, again, is another kind of off day for them where they can spend some of their own time. And then we talk to them Sunday night and give them some updates on what will be happening the following week. So that's kind of a typical day. There are atypical days where we're doing spacewalks or we're having visiting vehicles come and they'll reach out and grab them and pull them in. So those are kind of the special days, but so I hope that answers your question.
Hi, my name is Physaical, and how often do the astronauts aboard ISS switch out and get to come home?
Well, currently our average duration of the crew is about 6 months. A few days less, a few days more, depending on a few factors. We will have a crew coming up next year that will be up for a full year, and that's just part of our data gathering to see the effects on the crew being in weightless for a full year, but typically just 6 months.
Thank you.
Hi, my name is Kelsey. Have you ever had an emergency on board the ISS while you were working?
Well, that's a good question because, as you might imagine, we have very well developed procedures and actions, and we practice quite a bit for those occurrences. We've had quite a few false alarms. In other words, a smoke detector, will go off and we'll analyze the condition and decide that it was a faulty sensor or something like that. We've also had what we thought was a contaminated atmosphere, which was simply baking out of a absorbing material that had some gunk in it, so to speak, that smelled bad, but it turned out it was not really harmful to the crew. So no, I've not actually been on when we've had a actual emergency, and so far we haven't had any true emergencies on space station.
Hi, my name is Joe, and my question is, what inspired you to do your job and work with NASA?
Okay, well, when I was in junior high school, the first Apollo mission was going to the moon, and it was Apollo 8, and they flew a racetrack around the moon. They didn't actually land, but they just flew around the moon, and they did that on Christmas Eve. And so I can remember being with my family at a Christmas party at night, watching that on TV, and hearing from astronauts talking from the far side of the moon about their experiencing and reading from the Bible. And I thought, boy, that's something I'd really like to do. And so I kind of organized my life around preparing myself, studying, taking the courses, learning as much as I could, so someday I could be picked. I never was picked, but I really enjoy working in the space program.
Hi, my name is Duncan, and my question is, how hard is the training to work at mission control? What schools and places did you have to go to, and what is your degree?
Well, fortunate for me, I had a lot of experience in other jobs. I was a fighter pilot in the United States Air Force for 20 years. I had graduated from the Air Force. So I was well prepared for the job. Now, a lot of our folks who come and work in mission control are right out of college. And so it's a challenge to learn the precision of the business. In other words, sloppy work doesn't count for much here. You don't get partial credit for making a good try. What we really want is results, and we want people who are really focused on the important things of the job. So in that sense, if you're well prepared, it's not that difficult. But it is a challenging program. There's a lot of information to learn, a lot of facts and figures that you must be comfortable with. So it is a challenge for most of our flight controllers.
Hi, my name is Kendall. My question is, with communication being so far away, is it always easy to connect with ISS? Do you get glitch signals?
Well, this is an excellent question, and I just want to say that, like right now, we're having a period of time where the sun is at a very high angle over the station, and we're having some thermal problems with our KU antenna, a big dish antenna that you'd like see out on the outside of your house. And that antenna is getting too cold, so we can't use it right now. So we're not able to get video down and data up to the crew. So that's kind of a glitch. Every now and then we'll have the comm will break up, and we have to say things twice and all that. But normally our communications is very clear and very reliable, but from time to time we do have problems.
All right, and I understand that's our last question, but we want to thank you guys again for taking the time to ask some questions and learn a little bit more about the space station, and thank Hal for joining us. Thanks, guys.
Hey, thanks very much. I'm sorry for the folks. I need to answer a little quicker so we get everybody's in next time.